In this lesson, we're going to take a look at something we call special right triangles. They are used throughout mathematics, and we're going to start with the introduction of them here. So I'm going to start with what's called an equilateral triangle. Now we're all familiar with equilateral triangles, I hope. An equilateral triangle, all the legs are the same, all the angles are the same. And in this case, I want to know the height. What's the height of an equilateral triangle? Well, it might be best to start off by throwing some numbers on this problem. So we can use the numbers, and then we'll look at the general form. So in an equilateral triangle, this is all angles are 60, 60, 60, 60. Okay, and for sake of today's example, I'm going to call this 6 inches. Now obviously, not all equilateral triangles are 6 inches, okay? But today it is. I want to know how tall this triangle is. Okay, that's my height. Now, on an equilateral triangle, when you drop the height down, because along with being equilateral, it's also isosceles, it bisects the angle in half, and it bisects this length in half, the base here. So now we just created two triangles that look like this, where this is 3, 3, 60, 90, 90, 60. That's 30 degrees. So now we created two 30, 60, 90, 30, 60, 90 triangles. And because we dropped this guy down here, this was my height. Because we dropped the height down, those two numbers, those things will obviously be the same right here. It cut the bottom in half, cut the angles in half. Now my question still goes back to, what is the height? What is this height length here? Previous course, you talked about Pythagorean theorem. Now the Pythagorean theorem says, if I have a right triangle, that a squared plus b squared equals c squared. So if I have a right triangle, the sum of the square of the legs, a squared, b squared, is the square root of the hypotenuse. We're going to apply the Pythagorean theorem, to one of these triangles. So, let me make my life a little clearer. Pull this one out of here. We'll call this one A. That obviously has to be C because it's opposite there, and this one's going to be B. So what does B equal? So I want to know what B equals, so I'm going to subtract A from both sides. Okay, and let's go ahead and put some numbers in here. So B squared is 6 squared minus 3 squared. B squared is 36 minus 9. B squared is 27. Okay, this is B squared. I want B. To get rid of the square right here, I need to do the inverse. So we're going to take the square root of both sides, like that. Okay. Square root of b squared is going to be b equals the square root of 27. Okay, do not reach for your calculator. We will be doing square roots by hand. Now, of course, if you go down to the lumber yard and you say, hey, give me 11 square root of 11 feet of lumber, they're going to think you're kind of weird. So there are going to be times we have to use your calculator. However, we try not to because we want the exact answer. Now, this may seem like a stupid math trivial thing for your math teacher to bug you about, but for example, NASA, they had a calculation error that caused one of their rovers to smash into the surface of Mars. And its calculation errors, it turned out to be a rounding error, where they rounded something like maybe the square root of 27 instead of writing it out and carrying the digits or looking at the exact answer. Something like that can cause major problems. We won't do any rounding, any final calculations that require precision until the very last step, if at all, okay? So we are going to work with square roots without a calculator the best we can, okay? I will not, on tests and quizzes, I won't be accepting answers otherwise, okay? So let's take a look at this. B equals the square root of 27. So, square root of 27, I'm going to factor this down. I know 27 is 9 times 3, and the square root of 9. Now 9 is a perfect square, and what that means is if I had something that was 9 square inches, so a piece of something that big, 9 square inches, the dimensions of this would be 3 inches by 3 inches. This is where the idea behind a square root comes in. This is my perfect square. 3 times 3 equals 9. Now this works out well if I have 2 is going to be 4, 3, 9, 4, 16. That relationship is the square. 2 squared, 3 squared, 4 squared, etc. Only if they're perfect squares will they come out of a square root nice and clean. So what this looks like up here is this. Because 9 is a perfect square, 9 is going to come outside here as its square root. So then I'm going to have 3 times the square root of 3. Okay? That is your answer. The square root of 3 is that. We do not use our calculator and get 1.3 something. We leave it as that. So 3 root 3 is my answer. So come back over here. So this guy here is 3 root 3. Now, I want you to take a look at this, what we've done so far. Through a bunch of arithmetic, we were able to calculate the height of my triangle. The height of my triangle with sides of 6 was 3 times the square root of 3. Okay? I'm going to do this once more. I'm going to go through this one pretty quick. I'm going to do the same thing up here, but now, because I saw that 3 and 6 were, there's a multiple of 2 in there, so I said x and 2x. That's where it came from. I want to know what this length is going to be. Okay, I want to see if this 3 root 3 is unique to this triangle system I had over here, or if 3 root 3 leads to something else. So, x, 2x. So I'm going to do the same idea we did before. Let's just again call this one b. B squared is 2x squared minus x squared. This one here, I'm going to emphasize, got some parentheses in there. This 2 gets multiplied through like that, so I have 4x squared minus x squared. That's going to be 3x squared equals b squared. Square root of both sides. b, because those two are inverses. Up here, I can't take the square root of 3, but I can take the square root of x squared. If we went back to my square model again, it looks something like that, where the area is x squared. That means the side lengths have to be x. So it's going to be x root 3. Let's go back up to my triangle. This shows that that b length is x root 3. And this brings up the first fundamental special right triangle. So the 30, 60, 90 triangle has these properties. (60 degrees, 30 degrees). The short length across from the 30 degrees is a length of x. The hypotenuse across from the 90 is 2x. And finally, this middle length across from the 60 is x times the square root of 3. This is something you need to know. This will come up quite a few times in this quarter of math and throughout the rest of your mathematics career.